Hello, this is Mr. Wynn. Today's video will be systems of equations in 3 variables. So, like systems of equations in 2 variables, systems in 3 variables have either one solution, infinite solutions, or no solution. The solution of a system is called an ordered triple instead of an ordered pair. There's also ordered quadruple and things like that. So below are some visual graphs. So as you can see, this blue, green, and orange planes intersect at one point. That's one solution. Or in these middle pictures, they intersect at a line, infinite solutions, or they're the same thing, they're on top of each other. Then the bottom ones, they don't all 3 touch at the same time, just 2 of them. So for example, this middle picture, you never have the green and blue ones touching. Or this right picture, none of them touch at all. So again, make sure you know you have one solution, infinite solutions, or no solution. Now to solve them, you do the same thing you did for systems of 2 variables. You can use substitution, which you have a letter by itself, which is really rare, or elimination, which we will use a lot. That's the best method. It will be a lot more steps. It's going to take a lot of work. Some kids use front and back of the paper and it takes at least 5 minutes. So be careful. But our process is use elimination to turn the original 3 equations that has 3 variables into 2 brand new equations with only 2 letters, getting rid of 1. Then with those 2 new equations, we're going to use that, do elimination to get one final equation with only 1 variable, which we can solve. Once you get that letter, you plug it in and go backwards. So let's start. Example 1. I highly recommend you label your equations. So that's equation number 1, equation number 2, equation number 3. And you pick a letter to get rid of. I see the y's are very simple to get rid of. I can make that middle equation match the 2 on top easily. I can make them match the 3 on bottom easily. So using equations 1 and 2, I'm going to create a fourth equation, to make it match. I'm going to multiply this one by positive 2. So that'll give me negative 8x plus 2y minus 10z equals negative 72. So I'm going to write that, or actually let's drag this. I'll write it at the side. So my first equation, equation 1, is 3x minus 2y plus 4z equals 35. And equation 2 changed to this. Now that's not my new equation. My new equation has 1 less letter. So elimination just adds straight down. So 3x minus 8x is negative 5x. Negative 2y plus 2y is 0. That's supposed to cancel out. 4z minus 10z is negative 6z. And 35 minus 72 would be negative 37. That is my brand new equation. I'm calling that equation number 4. You see how this only has x and z? I successfully got rid of y. Now I'm going to try using 2 and 3, and I'm trying to get rid of y. So to make the y's match and opposite signs, I'm going to multiply this by 3 this time, positive 3. So that's negative 12x plus 3y minus 15z equals negative 108. So equation 2 is now this. Equation 3 is still the same. And just so you know, you could use you can multiply 2 things like before. You can multiply both equations by a number, but this time it was just simple. Only I multiply 1. And again, do elimination, adding straight down. So negative 12x plus 5x is negative 7x. 3y minus 3y is 0. This will disappear. Negative 15z plus 3z is negative 12z. Negative 108 plus 31, that gives me negative 77. So that's equation number 5. So 4 and 5 both only have x and z left. I'm going to ignore all the other equations and use those 2 only. So I'm going to figure out what letter to get rid of next. I'm going to get rid of z because I see 6 and 12. And I can multiply 6 by 2 to get 12. So let me go to this next slide. So equation 4 was negative 5x minus 6z equals negative 37. That was number 5. And number 6, oh, sorry, that was number 4. Alright, then equation 5 was negative 7x minus 12. Negative 7x minus 12z equals negative 77. That's equation 5. So now I'm going to choose to get rid of the z's. I have to multiply this first one. And remember, I have to make the numbers match and opposite signs. So I need to make it positive 12, so I multiply by negative 2. That gives me negative 10x plus 12z equals positive 74. So using those two, I'm going to do elimination, add straight down. Negative 10x minus 7x is negative 17x. Positive 12z minus 12z is 0. Cancel out like normal. And 74 minus 77 is negative 3. Alright, so I made a mistake. Try to catch your mistakes when you can. Negative 2 times negative 5 is positive 10x. So 10x minus 7x should give me 3x right here. So here's my latest equation. This is equation number 6. Now notice equation 6 only has one variable, so I can solve for x. All I do is divide. I get x equals negative 1. I have one of 3 letters. Now to find the second letter, you go back to equation 4 or 5, your choice. I'm going to use equation 4 because that's smaller numbers. So negative 5 times x, which is negative 1, minus 6z equals negative 37. Algebra, so it's 5 minus 6z equals negative 37. Going to subtract 5 both sides. Negative 6z equals negative 42. Divided by negative 6. I get z equals positive 7. I now have 2 letters. I'm just missing y. To find the last letter, go back to one of the original 3. So x is negative 1, z is 7. X is negative 1, z is 7. I'm going to use equation 1. So if I use equation 1, 3 times x, 3 times negative 1, minus 2 times y, plus 4 times z is 7, gives me 35. Algebra, so negative 3 minus 2y plus 28 equals 35. Combine like terms, negative 2y plus 25 equals 35. Subtract 25 both sides. Negative 2y equals positive 10. Divide by negative 2. We get y equals negative 5. So there are my 3 answers. Y equals negative 5. Now remember, it's a coordinate, so it's an ordered triple. So we need to turn that and say the answer is negative 1, comma, negative 5, comma, 7. Now, it'd be really nice to check. Plug into 1 to 3. If it works out, then you probably got all 3, right? So let's plug it into equation 2. If I plug it into equation 2, negative 4 times negative 1 is positive 4, plus negative 5, that's y, and negative 5 times 7 is negative 35, equals negative 36. If I combine terms, 4 minus 5 is negative 1, negative 1 minus 35 is negative 36, equals negative 36. That is true, our answer is correct. So that's solving a triple system. It's a lot of work. Turn 3 equations into 2 brand new ones with only 2 letters. Use those 2 new ones to get a 6th equation with only 1 letter, all by elimination. Then you solve for it, work backwards. So here's some more. Just know there are times when you get no solution and infinite solutions. So to speed things up, I'm going to say if we did the same steps we picked the first 2. So if I labeled equation 1, equation 2, equation 3, and I used 2 of them to do elimination, I would get 0 equals 0. Now when you see that, you say, oh, that's true. You think automatically all infinite solutions. 1, 0 equals 0 is not good enough for triple systems. You have to do it twice. So if I do the second and third equation, eventually I would get something like this. It'll say negative 34y minus 60z equals negative 120. Now that has some y and z for an answer. If it has some kind of solution, you're good. So that can't be no solution, we're good. So you have 2 check marks. So 1, 0 equals 0 and a true statement, just any equation that's true, or can be true, you have infinite solutions. So it'd be a lot of work to work it out, so I'm going to skip that. I'll just go straight to the main point idea. The second one, the bottom one, same idea. Say I label equations 1, 2, 3, and if I use 1 and 2, do the math, I get 0 equals 0, which again is good. So now I try the second one. I try 2 and 3. However, here I get 0 equals 5. The moment you see one thing that's false, a number equaling a different number, you can stop right away. So this is no solutions. Or you could just draw 0 with a line through it. Now, you don't have to use 1 and 2 first and 2 and 3 second. You could do 2 and 3 first and get 0 equals 5. So once you see something false, you're done, no solutions. But if you see a 0 equals 0, you got to take it one step further. Make sure the other one is not something false. Alright, and the last one, be able to write equations of triple systems. So here we have a girl, Heather, downloads television shows. Sitcoms are 0.3 gigs, dramas are 0.6 gigs, and talk shows are 0.6 gigs. She downloads 7 total for 3.6. And there are twice as many episodes of dramas as a sitcom. So let's do the total first. I'm going to call sitcoms S. So the number of sitcoms plus I'm going to call dramas D, the number of dramas, plus the number of talk shows T is 7. That's one equation. Next, she tells us she downloads a total of 3.6 gigs. So I'm going to do a gigabyte equation. Well, each sitcom is just 0.3 gigs for each one, plus each drama is 0.6 for each one, and each talk show is also 0.6 for each one, and the number of gigabytes total was 3.6. Now lastly, they say there are twice as many episodes of the drama as the sitcom. So I'm comparing sitcoms and dramas. Now, which one's more? There's twice as many dramas. So that 2 does not go with drama. You're making a bigger number bigger. That's wrong. The 2 helps the number that's smaller. So I'm putting the 2 with the S. Double number of sitcoms gives you the number of dramas. Now, you have 3 equations with 3 letters. We could put in standard form and then do elimination until we get one thing and then work backwards. So make sure you know that the number of letters tells you how many equations you need. If you have 5 letters and only 4 equations, that's impossible. If you have 5 letters and 5 equations, that's fine. Just a lot of work. 3 letters, 3 equations, 2 letters, 2 equations, things like that. Alright, here's your practice problem. Try solving it. I recommend using elimination. It will take a lot of space on your paper, and there's the answer. If you have any questions, ask in class. Thanks for watching. See you then.